All right, everybody, this is the Algebra 1 8.2.2 lesson today. It's in the zero product property, and for the most part in this one, I know the last one I didn't follow the book too much. I'm kind of going to follow the book a little bit here. All right, I'll go through their examples. I won't necessarily go for their answers question by question, but I'm going to use them. Why not, you know? All right, so the big thing here today is we're going to learn the zero product property. Key vocabulary that I'm seeing right off the bat in blue are zeros, roots, quadratic equation, and zero product property. Now, we already did the quadratic equation already, okay? That was in the form y equals ax squared plus bx plus c. And what makes a quadratic equation is straight there, that x squared. You do not need any of these other guys as long as you have an x squared. So the essence of question 864. Okay, so 864 is asking you how many points do you need? And important points on a parabola. You should be able to find the x-intercepts and the vertex. All right, I'll be honest with you. Those are really the only 3 points you need. The y-intercept is also helpful because that's kind of like what we had as our starting point, but those are the 3 things we need, or the things we need to have. You should usually have 2 x-intercepts. You'll have 1 vertex and 1 of these. So how many points you need? You need about 4 points, or you could have 3. I'll be honest with you. If I have a kid that has this guy and that guy, I'm good to go. I don't really need the y-intercept. I would just make sure that it makes sense in the equation. All right. So we kind of talked already about this. So they go through all of these questions and they ask, okay, if you just knew about the y-intercept, so let's say I just knew the y-intercept on this guy, so I'll actually put this here. If I just knew my y-intercept, let's say my y-intercept is right here. Could I draw my parabola? Well, kind of couldn't, right? Because this would go like this. It could go like that, right? It could go, it could do this. Okay, all those things happen. So the y, this is part A, y, no, it doesn't work. I need to have more than just that. There's too many parabolas I can draw, all right? Then the next thing is, what about 2 x-intercepts? If you only know the x-intercepts, can you draw the parabola? For example, if you have -3, 0, so -3, 0 is here, and 5, 0, can you draw your parabola? Not really, because couldn't it do something like this, right? Couldn't it do something like this? So no, that's not. So it's getting to what I said before. I need more. So in part C, sketch it with only its x-intercepts and its, can you sketch it with just its x-intercept and its y-intercept? So here we go. All right, so that's the x-intercepts. And the y-intercept was at, what, 0, -15? Now, I'm not going to get down there, but let's say I could if I got down here. Right down here, okay? So, would it make sense? This is kind of the big deal here, because I'm not going to get the exact sketch, you guys. That's just not happening. All right. Would it make sense that in order for me to find the vertex, wouldn't I have to have the middle here? And if I knew the y-intercepts down here, I know the vertex is down here somewhere. And this is obviously not -15, so I know I can't count. It's just not going to fit on here. All right, so between here and here, this is like, what, 1, 2, 3 here, and that's 5 there. Wouldn't smack dab, I think it'd be right here, right? That 1, okay? Because I'd have 1, 2, 3, 4 units here, 1, 2, 3, 4 units to the left. So if I could figure out when your x is 1, what the y is, I'd be able to know where the parabola is on the bottom, and then I could go, oh, there it is, right? That makes sense. So I actually gave you and see what's the line of symmetry. So if I knew that the x is 1, I would go through there. So would it make sense on this one if this is my table, right? So far, I know of an x of -3. My y is 0. I know when my y is, or my x is 0. My y, this guy right here, because it didn't hit it. It's wrong. It's bad. I know. I'm sorry. It's 0, -15. I also know here that at this point, I have 5, 0, but then I know the vertex is at 1 something, right here. Let's do, vertex is at 1, right? But I don't know what that is. right? So I don't know what that is, so that's okay. But then I also know my other one is at 5, 0. Okay, so those are my 4 points. So if I know those, I'm good to go. So I had to figure out a way to figure out this point, because then I would be able to draw my parabola, right? Okay, so that's the essence of it, okay? But the big thing here again, okay, if I know my x-intercepts, okay, the x-intercepts, then the vertex's x-coordinate has to be smack dab in the middle, right? And that's it. We have to figure out how we're going to find that middle. All right, so I'm actually doing my ebook right here. So that's 864. We're done with that. So we need these two, and this is really good as well. 865. In the previous problem, you learned what you can find. You can find the x-intercepts to find the rule of the parabola. Then can you sketch it without a table? Okay. So what's true of all the y's for all the x-intercepts? So we should know x-intercepts are always in the point. Some number is your x, 0 is your y. So there we go. What is true about all your y-intercepts? Your y is always a number and your x is always 0. We've discussed that before. All right. So this is everything in it, in A. So in B what they do is they discuss how are you going to find your y-intercept. Okay. So here's the equation. I should probably put this right up here. So I'll erase the B, and this is the guy that we're working with, okay? Okay, y equals, we're going to 2x squared plus 5x plus 12, okay? Here is what we are going to do. We're going to find the y-intercepts and then the x-intercept. All right? And then what I'll do is I'll go on my little fun grapher and I will graph that for you, okay? So, sorry, I'm erasing everything right now. So the first thing I'm going to do is I'm going to find the x-intercept, and I am going to change that y to 0. Or, I'm sorry, the y-intercept, we're going to change x to 0. Okay, so if my x is 0, here we go. Y is going to equal whatever 2 times 0 squared is, plus 5 times 0, plus 12. All right. Oh, sorry, it's minus 12. My bad. Go back. Minus 12. It's going to make a difference for this one. All right, so 0 squared is 0 times 2 is 0. 5 times 0 is 0. Y equals 0 plus 0 minus 12. Y equals negative 12. So I know I'm definitely going to have a point at my x was 0. My y is negative 12. Fantastic. X-intercepts. Okay, for the x-intercepts, don't you make your y 0? All right. All right. So what I need to do, I need to figure out a way to get this thing. Okay. And I'm probably going to get ahead of the game, you guys. But I can. I need to figure those out. And I want to guess and check forever. So I'm going to come back to this in just a second. I want to go off the beaten path here because that's what I do, right? Okay, guys, if I gave you a number times another number and I said that it equaled 0, what would one of those numbers be? Well, one of them has to be 0. Or wouldn't both have to be 0? Okay. Let's say I had, I'm going to make this x now because we're in algebra. Let's say I had a number x times 3 times a number x, and that equaled 0. Could you tell me what x is? Right. X has to be 0. Right? Because one of them, if they're all multiplying, one has to be 0. Okay? So I'm getting ahead of the game because this is 866, but this is one of your vocabulary words. It was zero product property. Okay, the zero product property just means I can be multiplying 2 items together. I can be multiplying 3 items together. I can multiply 1,000 items together. And if the product of those items is 0, one of them, a few of them, all of them, but at least one of them has to be 0. Okay? So if 2 or more terms have a product of 0, then at least one term is 0. All right. So what you'll see is I'm going to go like there's going to be something here times another something here equals 0. Either this one is 0 or this one is 0 because that's going to be popping up here. All right. Just because I feel like CPM is going to be nice to me and this is going to actually work. All right. Going with the 0 product property. Oh my gosh. This is right here, you guys. This is the sum. How do I change a sum into a product? Ding, ding, ding. Yep. We got factoring. So changing a sum to a product is factoring. I'd write that down too. All right. So for those of you that weren't getting that quick check ready last week, this is why I was worried, because we have to do this now. All right, here we go. Let's factor this bad boy. So here we go. Box, diamond. Hopefully this can be factored. I totally didn't do this before. So I got 2x squared here. Negative 12 goes there. Now, other teachers put them in these spots. You guys, it totally doesn't matter, okay? It has to go in diagonal. Then the next thing we said is that these two multiplied together is negative 24x squared. That goes on the top here. And then the bottom is this middle term. Oh, I think we got one. So remember, these two have to multiply to give me negative 24x squared and add to give me 5x. I'm feeling like it's going to be 8x and 3x. Because 8x minus 3x gives me 5x. 8x times negative 3x gives me negative 24x. Fantastic. Let's throw an 8x here. And let's go with a negative 3x there. All right. Now, I skimmed through some of your homework, and this is where some of you guys have to kind of be a little better about things. 2x squared is definitely 2x and x. Now, I need a 2x to make a 2x and an 8x. 2x goes here, okay? So this would have to be x. 2x times x is 2x squared. So 2x times, so 2x goes here, 2x, I put it there. That's just what I do. 2x times something is 8x, that's 4. 4 goes here, 4 goes there. 4 times something is negative 12. That's negative 3. Negative 3 goes here, negative 3 goes here. Negative 3 times something is x. Ooh, yeah, that makes sense. All right. So here we go. So if I have a 2x minus 3 times an x plus 4, that's this. So that equals 2x minus 3 times an x plus 4. Okay. So to get the x-intercepts, I have two items here. Okay. And I'm actually gonna get a sheet of paper and I'll bring this thing down. I cannot manipulate paper today. Here we go. All right. So I'm gonna actually sketch this thing. I'm gonna see where my x-intercepts are and I'll see if I can put it on my iPad. So here we go. If this works, so I have my y-intercept, okay? And then I'm going to have a 2x minus 3 times an x plus 4, that equals 0. So either this guy equals 0 or this guy equals 0. Because that's an item. This is saying one thing times another thing equals 0. So one of those things has to be 0. So this one I'd subtract 4. X equals negative 4. This one we're going to add 3. X equals 1 and 1/2. So we have x-intercepts at 1 and 1/2, 0, and then negative 4, 0. So I'm going to tell you right now, I'm not going to get a great graph on this because I just want to explain how we would get the vertex. We're not going to get the vertex for now. So here we go. My x-intercepts were 1.5, 0. It's right here. And then negative 4, 0. Out there. And then what did I say my y-intercept was in this? Negative 12. That's going to be way down here. Okay. So in order to find the vertex, we'd have to go between here and here. So it's somewhere in here. And we would have to find that x value, plug it into the equation, and find the y to see how far it goes down there. Okay. But for now, we're not going to do that. That's just what we would have to do. Okay. I'm assuming that a lot of this stuff, as far as graphing goes right now, yeah, I'm looking at it. They're not going to make you graph too much. They just want you to find the x-intercepts, knowing that between there, you'd find a x, and then you'd have to figure out the y for that x in order to graph it. Okay? So that's that. All right, so what I did is I kind of started to look at 66. I did 65, but then if you are paying attention to your ebook, there is vocabulary there, okay? So zeros or roots. Zeros and roots are the same thing, you guys. And if I look on here, Okay. Ooh, yeah. So they actually use the example. A root of an equation is a solution. Okay. And it is your x-intercept. Zeros is a number often used to represent having none of one quality, but a zero. Zero is neither even or odd or an additive. They just mix that up. That's so weird. Sorry, I didn't mean to do that. Okay, roots are zeros. I know what I'm doing. Roots are zeros. These are your x-intercepts. For an equation. It's just another word. I say AKA all the time. All right, so that's 866. So 866 or 865. And then in 866, you guys, they actually talk about the quadratic equation. We have that already. We threw in the zero product property. I have that as well. So then in 867, what they have you do is what I just did with you, was to find the x-intercepts algebraically for 2x squared plus 5x minus 12. I already did that. We're going to look at 868. So for this one, we're going to find the x-intercepts. And then the y-intercept. And then we're going to decide, can we find the vertex? Okay? Is this one that I would want to find the vertex that way? Because there's going to actually be a better way to do this as well, okay? So, with that in mind, here we go. So finding the x-intercepts. Our equation here is y equals x squared minus 2x minus 8. All right, so for the y-intercept, remember this is where x equals 0. So y is going to equal 0 squared minus 2 times 0 minus 8. Y equals 0 squared is 0. This is minus 0 minus 8. 0 minus 0, 0 minus 8. Y equals negative 8. So if I have to graph this, there's going to be a point at 0, negative 8, if I can. I want to be doing something nice here because we've had some difficult things. Your x-intercept. All right. So your x-intercept is when y equals 0. Okay, so we're going to make y equal to 0, and we're going to have x squared minus 2x minus 8. So I'll actually write the steps off to the side here, you guys. So first thing, to find your x-intercepts, you're going to make y equals 0. Next thing we're going to do is we're going to factor. Okay, just because I want a line here, I'm going to factor right here. So I'm going to factor x squared minus 2x minus 8. So when I ask you guys to factor box and diamond, all right, we should know, sorry, that went off there. We should know at this point that in the diamond, you should have an x squared and a negative 8 in the diagonals. You multiply those together to get negative 8x squared. In the bottom goes the middle term all the time, just because it always does. Now, we know that these guys add up to be negative 2x, and they multiply to give me negative 8x squared. I'm feeling like I'm going to do a 4x and a 2x to get negative 2. That's going to be negative 4. Negative 4x plus 2x is negative 2x. Negative 4x times 2x is negative 8x squared. Here we go. X squared is x and x. X goes here. X goes there. Negative 4 goes here because negative 4 times x is negative 4x. Negative 4 goes here. Negative 4 goes there. Negative 4 times 2 is negative 8. 2 goes here. 2 goes here. 2 times x. So it looks like this factored is x plus 2 times an x minus 4. You guys okay with that? Good. So going back up here, 0 is going to equal, it factored is x plus 2 times x minus 4. That's the next thing. Now, you have to think about this. This is something times something else equals 0. So either this thing equals 0 or this thing equals 0. So that step is setting each factor equals 0. Okay, we're setting each factor equal to 0. So now I'm going to solve this. Subtract 2. X equals negative 2. Add 4. X equals 4. So we're going to have x-intercepts at negative 2, 0, and then 4, 0. So we said there were four points you needed to have. 2 of them were x-intercepts, then a y-intercept, and then a vertex. Now the last problem we did, the vertex was hard to find because we know that vertex is smack dab right in the middle of those x-intercepts, right? So here we go. Let's start graphing this thing. I got these guys, and I know I can fit this on my graph, so I'm feeling pretty good about this. All right, so here is mine, and I'll probably go back to my paper in just a second, but I want to get these on here. 0, negative 8 is my y-intercept. 1, 2, 3, 4, 5, 6, 7, 8 is here. Ooh, do I not have 1, 2, 3? Hopefully that works. Yeah. Okay. Okay. 1, 2, 3, 4, 5, 6, 7, 8 is there. Good. I'll make that a little bigger. And then negative 2 zeros here. And then 4 zeros there. All right. So I need to give you guys a way to find the middle. And one way that you can find the middle, make this a light pink, is that you can just count in. So there's 2 here, there's 2 there, 1. It looks like it's probably going to be at x equals 1 right there, right? Because I go 1, 2, 3, 1, 2, 3. Totally makes sense. Here's the other way. So that is where x equals 1. Let's see what mine is, yeah. So that's where x equals 1. The other way you guys can get that x equals 1 is you can take your x-intercepts, which are negative 2 and 4, and find the average. Remember, averaging is you take those, add them and divide it by 2. Negative 2 plus 4 is 2. 2 divided by 2 is 1. There's your 1 right there, okay? So here's what we know. We know for sure that your parabola goes down like this, right? Probably goes down a little more. And we know that it has an x of 1, okay? So I can find that if x is 1, can't I go back into here, shove this up here, okay? Can't I go back into this equation, put 1 in for the x, figure out the y, and that'll tell me the point right here? Here we go. Let's do that. Let x equal 1. This is the middle of your zeros. I'm using the word zeros to get you new vocabulary. Remember, that's your x-intercept. So y is going to equal, our x is, shove this up a little more, our x is 1. We're going to take 1 squared minus 2 times 1 minus 8. Y equals, this is 1, negative 2 times 1 is negative 2 minus 8. Y equals, 1 minus 2 is negative 1 minus 8, that's negative 9. Equals negative 9. So, here's my stylus here. I'm going to change my colors and we'll get something a little darker. We'll do green. So at 1, negative 9, let's see, here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9 is right here. When the heck is that not going? Here we go. Then if it's if we have lines of symmetry, you guys, would it make sense that if there's one here, there'd have to be a point right there, and those two are evenly spaced? So this is not the best parabola in the world, but here we go. All right, so there you go. It looks kind of like this guy is a little higher up, but it should be down a little bit more. All right, so that's my parabola. And that's all that I need to know, okay? So the other thing kind of to go with everything else was, okay, I think I mentioned to you guys, what do I have to make all of the table? No, I don't have to make all the table now. For a problem like this, you guys, would it make sense for x's and y's? If you know your x-intercepts are from negative 2 to 4, I could go a little smaller than negative 2 and go negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, maybe 5. There you go. All of my numbers would be in here because wouldn't all of those x's be right in here? And I'd find all the points for my parabola. All right, so that gets us through all of that. Probably do a little bit more than that of that. If I get a bunch of questions this week on this stuff, I'm totally going to make up some more problems and I'll show you guys how to find the zero product, but that is important and that is why we factor. So looking at your homework, this will be online. It's going to be questions 869 to, okay, we can do 70, 71 is good, 72 is good, 73, 74 is good. Ooh, we're factoring again. I love, remember for factoring though in 74, you need to make sure you take a GCF out to 75. All right, there you go. And